Hi everyone. This is a quick video explanation of the XploreR project, Autonomous Exploration with Virtual Reality Visualization, a cooperation between the Karelics company and University of Eastern Finland. This project was done for the subject of robotics and XR in the master program Imaging and Light in Extended Reality. So, first of all, the XploreR project's goal was to implement autonomous exploration into the Sample2 robot. So, autonomous exploration strategies, they enable the robot to autonomously select a new goal location to travel to. And it can have multiple goals for the choice of which goal to pick. It can either go for the shortest path or it can go to a location that explores the most area. These goals, they are set according to the robot's occupancy grid, where the unknown areas are detected as frontiers. So in the image, you can see some blue and red lines. Those frontiers are then used to set a goal target. And in the image to the left, the goal targets are all the green spheres. Then the robot selects one of those green spheres as its goal. Our first part of the project was implementing this autonomous exploration strategy. And then, furthermore, we wanted to visualize the generated map in a virtual reality scene. For this project, we used multiple environments, including Docker, ROS2 Galactic, and the Unity game engine. An overview of the project is shown here. For our project, we had two situations. We had one with the real robot and one in the simulation environment. Here you can see, for example, we used the TurtleBot 3 simulator shown on the left side. In the TurtleBot 3 simulator, we can get some of the data that it's pretty much the same as the Sample2 robot. So for the autonomous exploration algorithm, we need the cost map of the robot, and with the cost map we can then apply our autonomous exploration algorithm to then detect frontiers, which we can then publish to a topic. And from these frontiers we can also use an action from the robot to set a new target goal, and the target goal will then make the robot move to that goal. To connect the simulation or the robot, all the data in ROS2 with a Unity scene, we used a package called ROS2 TCP endpoint on the ROS side and a plugin called ROS TCP connector on the Unity side. This allows Unity to access all the topics that are being published in the ROS domain. And then in Unity, we developed a VR scene for visualizing all the data. We got three outcomes from this project. First, as I mentioned before, we have a simulation in Gazebo using TurtleBot 3. In the simulation, it's Dockerized, so it will be a service in Docker running the simulation, another service running the exploration node, and a service just for the ROS TCP endpoint to connect with Unity. Then we also have our simulation in the Unity side, with connection to ROS2 and the VR scene in Unity. And for the real robot, we have the Karelics robot Sample2. All we had to do was connect the robot to the network and do some fine tuning and launch the exploration node in Docker for it to work. Here's a teaser video of the project in action, some of the different situations that happen in the project. So first of all, we have the autonomous exploration in the TurtleBot world in the Gazebo simulation. This is the default map or world, as they call it, in the Gazebo simulation, and you can see the robot explores the whole map autonomously. Then we have the visualization VR, and you can see the map being generated in the Unity scene with the VR headset view in the bottom right corner of the screen. Here you would just see that the map is the same as the one in the Gazebo simulation. We can visualize it in VR. And then we have a test run of the robot exploring the Karelics office. And here you can see, if I pause the video, you can see on the right side the RV's view. The blue lines are all the detected frontiers by the algorithm. The green spheres are all the possible goals, and the robot is going around the office exploring it. And here you can see that the robot stops and the exploration is considered done, because the cost map, all the possible areas that the robot can move defined by the cost map, the clearer area, the lighter area, have been explored. So all the available goals, the robot can't set a valid path to them. So in this situation, the exploration is considered done. The other possible situation that the exploration would be considered done is if there are no more frontiers detected, which is what happens in the Turtlebot 3 world in the simulation environment. And here we show a small video of the robot exploring the Karelia Hall when we did our demo test for the Robotics and XR exhibition. For further information about the project and links, you can access the GitHub repo, where all the code is available, including the presentation slides, the project report, and the very extensive README of how you can launch the project yourself. Thank you very much.